Okay, class, so we'll be doing the next lesson, which is solving equations using squares and nth roots. This is exactly why we need to know how to square and cube root something when we're solving an equation with x squared or x cubed. Eventually, when you go to Algebra 2 or Math 2, you'll be solving for things that kind of like when you're solving using the Pythagorean theorem, you need to isolate x and um, whether it be cube rooting something or square rooting something, you need to know how to do that. So it says, what does an inverse operation do? We've been using inverse operations our entire pre-algebra and algebra years. So we know that an inverse operation simply just cancels the previous operation, or it kind of cancels a pre-existing situation, pre-existing operation. And we use inverse operations to help isolate x. Isolate the variable, right? Whether it be add and subtract, multiply or divide, square or square root. Consider the equation x squared equals 25. Is 5 the only solution? Is 5 the only number that makes the equation true when substituted for x? So again, I've been saying this in previous lessons. I've been saying this in previous modules. It's really important that we understand that x squared is an even function. Okay, we know this is an even function because the power is an even number. Okay, and if you were to graph this, you will be doing this a lot in future classes, future courses. X squared looks like this. Okay, it looks like a parabola. We start at the origin, we go up, and we just keep increasing. Definitely not linear, right? This is a parabola, and this is what all quadratics look like. This is a quadratic equation or function. It's a quadratic because the power is 2, and quadratic functions are even functions, right? So because of this, you can see that if I were to increase my x value to the positive side, it actually has the same y value as the negative version, right? 2 is going to equal 4. Negative 2 squared would also equal 4, right? So for this reason, even functions, when you're solving them, we know that, oh, well, how do we cancel the square, right? What's the opposite for squaring something? Well, you should realize that it means to square root it, right? If we square root a square, it will directly cancel it, right? Because we know that this number outside is a 2, and we divide this power by 2. So this ends up being x to the 1, which we know is just x. And we get 5. And I know 5 is the one that seems like it's obviously 5. But the thing is, with every even function, you always have to account for the negative counterpart, right? So you have to realize that 5 works and negative 5 also works. Okay, this is only true for even functions. Later on, when we deal with odd functions, we don't really have to worry about the positive and negative because there's only going to be one answer for that. Okay, so even functions, always look out for positive and negative. Consider the equation square root of x equals 5. Is 25 the only solution? So this is a little bit of, yeah, this is a very, very good concept. When you have square root of x equals 5, you want to square both sides, right? Essentially, you want to square the entire thing. So if you square the entire thing, it's still the same answer. And the square root of x squared is going to be equal x, and then 25 is the only answer here, though. So we have two answers when we're solving for x in this method, but when we have square root of x equals 5, the only answer is 25. if you were to think about it too, the reason why it can't be negative 25 is because the square root of negative 25 is no solution. It doesn't even exist, right? So this is kind of like, I can see why you may be thinking, well, why is it so confusing? Why is x 5 and negative 5? But when you're solving for this one and you square both things, the answer is only 25. Well, I think the quick answer to that is 5 squared is always going to be positive. So if you just think about it, 5 squared is always positive, and there's no way that this square, or any square for that matter, should ever be negative. So you can even write something like squares must be positive. Okay. I hope that makes sense. Okay, so now we're going to go ahead and solve. We're just going to be using the inverse operation, whether it be to square root here or to square. Okay, so I'm going to go ahead and square root both sides. We know this is an even function, and hopefully you are familiar with the square root of 100. You know that x is going to equal 10, and x is also going to equal negative 10. Sometimes people write this as plus or minus 10 like that. Honestly, I just actually prefer this. It's a little bit, I think it's just more clear. This one, of course, also works. Here we have x squared equals a negative 36. So we just wrote in the previous question that squares must be positive. So this should tell you that this is an issue right here. How does a square ever equal a negative, right? This should be no solution. You know that a square must not be negative. Also, if I were to square root both sides, you would get x equals the square root of negative 36, and that does not even exist. Later on in Math 2, I believe, you will learn about I, the imaginary number. We're not there yet. But yeah, this would be 6i, positive and negative 6i. So, yes. Okay. Here, again, you probably can do this on your own at this point. But I'm going to square both sides. You get x is equal to 81. That's your final answer. Here is actually similar to, D is similar to letter B, right? How could you have a square root ever equal a negative, right? So we know that you can't square root negative numbers. So if you can only square root positive numbers, the square root of a positive number should always equal a positive number, right? The square root of a negative number does not exist. So there's no way that the output should ever be negative. This is also no solution. Okay. We're just using inverse operations today. Okay, so I think here, this portion of the lesson, you have to be very, very clear why it doesn't exist. When you square something, it should never be negative. So you'll see that this lesson has a lot of curveballs. Right away, number 5 gives you x squared equals negative 64. And I don't even have to do anything. I know that this should not be negative. This is no solution. Okay, here it's interesting because number 6 we have a coefficient in front of y. So just like we've been doing for a long time, you always want to divide away the coefficient, and you get the square root of y is equal to 1/3. Okay, so far so good. We have a square root, and we also have the output of it being positive, so we know that that's okay. So then now we just square both sides of the equation to cancel out the square root. Remember, our goal is to always isolate the variable. So if we have the variable with a root on top, we have to destroy the root by a square. You have to cancel out the previous operation with a new operation. These two are inverse operations. So your y value is really just 1/3 times 1/3, which we know is 1/9. Okay, I really encourage everyone to try this. As I'm doing this, hopefully it's helpful for you to have a visual. But I actually think that this is really, really good practice, right? So you don't always have to watch the video as the first step. Maybe you want to try these problems yourself and then see if your answers are the same as mine on the video. Okay. A squared is equal to 1/8. You want to square root both sides. And the thing here is we have to be careful for the plus and the minus, the positive and the negative, right? This just like here in 4a, when we had x squared equals 100, you need to account for the positive, which I think is obvious, but you also need to account for the negative, right? So here's no different. A squared equals 1 equals the square root of 1/8. So this brings us back to the concept of how do we simplify the square root of 1/8? We know that the denominator must always be rational. So right now, we know that the square root of 1 is simply just 1. The square root of 8, what is that, right? That's the square root of 4 times the square root of 2. And the square root of 4 is a whole number of 2, square root of 2. But you then have to fix this denominator, right? The denominator is not allowed to have a root like this, so you have to rationalize it by multiplying both the top and the bottom by the root. So you get 1 times the square root of 2, which is the square root of 2, and then you get 2 times the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is just 2. Right? The square root of 2 times the square root of 2 is actually the square root of 4. And then the square root of 4 is actually 2. So then 2 times 2 is 4. So people think that the square root of 2 over 4 is the final answer. But what did I forget to place in front, class? You have to remember, plus the positive exists, and so does the negative, right? Because this is an even function. This is a very, very important question. I would put a star next to number 7. Not only is it asking you to find the positive and negative number for A, it also is asking you to rationalize the denominator. I guarantee you will see a problem like this again in future math classes, especially when you're solving for the hypotenuse of a right triangle. You won't always deal with numbers that are so nice and friendly, right? So sometimes you will have to rationalize the denominator. You will have to multiply the top and the bottom by the root. It's just when you go on to high school, you'll realize the numbers are not always so clean. So this is a good example of that. Okay, number 8, 3x squared plus 7 equals 97. This is now what I would call like a 3-step equation, multiple step equation. We know to always subtract away or get rid of the constant. The constant is already known. We just need to get rid of it. So we get 3x squared is equal to 90. Then we divide both sides by 3. We cancel the coefficient, just like we normally have been doing, and we get x squared is equal to 30. Again, you should realize that this will give you a plus or minus answer. You need to provide both the positive and the negative. The positive is the one that comes obvious, but since this is an even function, you have to give me the negative as well. So I'm going to square root. And really, again, you can see how this is like a simplifying square root type of question. So what is the square root of 30? Is the square root of 30 already simplified? The answer is yes, it is. There's nothing you can do because a perfect square is not a factor of 30. So there is nothing you can do to make it more simplified. It already is simplified. The only thing you have to remember, though, is you have to give me plus or minus. And I realize plus or minus is better for saving space, so I'm going to start doing that. But you have to give me the plus or minus. If this was if we were still in school and we were giving tests and students forgot to give me the plus or minus, you would realize you're forgetting one half of the answer. So that would be a very, very costly mistake. Okay. Let's take a break right here.